When writing code, it's important to keep it organized. This is not just a best practice, but a necessity for long-term project success. Organized code is easier to read, understand, and maintain, which is crucial when working in a team or revisiting your own code after some time. This is especially true as your projects grow larger. As the complexity of your project increases, so does the need for a clear and logical structure. Without it, you risk creating a tangled web of dependencies and functionalities that can become a nightmare to manage. Imagine a house with all its rooms and belongings just thrown together in one big pile. You wouldn't be able to find anything, and living in such a space would be incredibly stressful and inefficient. It would be a nightmare to navigate and find anything. The same principle applies to your code base. If your code is disorganized, it becomes a daunting task to locate specific functions or debug issues. In the same way, disorganized code can be difficult to understand, debug, and maintain. It can slow down development and lead to more bugs and errors, as developers struggle to make sense of the chaos. It can become a jumbled mess of functions, classes, and variables. This not only hampers productivity but also increases the likelihood of introducing new bugs when making changes. This makes it hard to find what you're looking for, and even harder to make changes without breaking something. The more disorganized your code, the more time you'll spend trying to understand it rather than improving it. This is where the concept of code organization comes in. By structuring your code logically, you make it easier for yourself and others to work with it. This involves using clear naming conventions, modularizing your code, and keeping related pieces of code together. Just like a well-organized house, well-organized code is a joy to work with. It reduces stress, increases efficiency, and makes the development process smoother and more enjoyable. It's easy to understand, modify, and expand. When your code is well organized, you can quickly locate the parts you need to work on, make changes with confidence, and add new features without fear of breaking existing functionality. In Python, modules and packages are essential tools for achieving this organization. They help you break down your code into smaller, more manageable pieces, making it easier to navigate and maintain. They allow you to break your code into smaller, more manageable pieces. This modular approach not only makes your codebase cleaner but also promotes code reuse and easier debugging. This makes your code more reusable, readable, and scalable. By investing time in organizing your code, you set yourself up for long-term success, making future development faster and more efficient. In Python, a module is simply a file containing Python code. It can include functions, classes, and variables that you can use in other Python programs. Think of a module as a toolbox containing specific tools for a particular task. For example, you might have a module called math_operations.py that contains functions for performing various mathematical calculations. This way, you can easily reuse these functions in different parts of your project, or even in other projects. Modules provide a way to organize and reuse your code, making it more efficient and easier to maintain. Instead of writing the same code over and over again, you can put it in a module and import it whenever you need it. Now that you understand what modules are, let's see how to use them in your code. This is where the statement comes in. The statement allows you to access and use the code defined in a module. Let's say you have a module named my_module.py in the same directory as your current Python file. You can import it like this: import my_module. This line of code tells Python to look for a file named my_module.py in the same directory and import the code it contains. Once you've imported a module, you can access its functions, classes, and variables using the module name followed by a dot. For example, result =, my module, my function, 5, 10, print, result. This code snippet assumes that my_module.py contains a function called my_function that takes 2 arguments and returns a value. In Python, you have 2 ways to import modules: absolute imports and relative imports. Understanding the difference between these 2 methods is crucial for organizing your code effectively and avoiding common pitfalls. Absolute imports specify the complete path to the module you want to import, starting from the root of your project. This means you provide the full path, which makes it clear where the module is located within the project structure. Relative imports, on the other hand, specify the path to the module relative to the current module. This can be useful when you are working within a package and need to import modules from other files within the same package. Absolute imports are generally preferred because they are more explicit and less prone to errors. They make it clear exactly which module you are referring to, regardless of the current file's location in the project structure. For example, consider the statement, import my _package.module_a. This line imports module_a from the my_package package using an absolute import. This method is straightforward and reduces the risk of importing the wrong module. This clarity is particularly beneficial in larger projects where the directory structure can become quite complex. Absolute imports help maintain readability and manageability of the code base. Relative imports are useful when you are working within a package and need to import modules from other files within the same package. They use dots to indicate the relative path, which can make the code more concise. For example, the statement from import module_b. This line imports module_b from the current package using a relative import. The dot indicates that the import is relative to the current module's location. While relative imports can be convenient, they can also lead to confusion if the directory structure changes or if the code is moved to a different location. Therefore, it's important to use them judiciously. In summary, both absolute and relative imports have their place in Python programming. Absolute imports offer clarity and reduce errors, making them ideal for larger projects. Relative imports provide convenience within packages, but should be used carefully to avoid potential issues. Section 5. Organizing your project. Creating a multi-file structure. As your projects grow larger, it's a good practice to split your code into multiple files. This not only makes your code more manageable, but also improves its organization and readability. Instead of having one giant file with thousands of lines of code, you can break it down into smaller, more focused files. For example, imagine you are building a simple game. You could have separate files for handling the game logic, graphics, sound effects, and user input. This way, each file would be responsible for a specific aspect of the game, making it easier to understand and maintain. To create a multi-file structure, you simply create multiple Python files within your project directory. Each file can contain functions, classes, or variables that are related to a specific aspect of your project. Section 6. Packages in Python. Taking organization to the next level. Packages in Python take code organization a step further. A package is essentially a directory that contains multiple modules. Think of a package as a container for related modules. It provides a hierarchical structure to your project, making it easier to manage and navigate. For instance, if you're developing a web application, you might have separate packages for handling user authentication, database interactions, and template rendering. Each package could then contain multiple modules responsible for specific tasks within that domain. Creating a package is simple. You just need to create a directory and place an empty file named inside it. This file signals to Python that the directory should be treated as a package. Section 7. The special file. Initializing your packages. The file plays a crucial role in Python packages. It's not strictly necessary for simple packages, but it's considered good practice to always include it. This file can be empty, or it can contain initialization code for the package. When you import a package, the file is executed first. This allows you to define any package-level initialization code, such as importing specific modules or setting up configuration variables. You can also use the file to control which modules are imported when a user imports the package using the wildcard. For example, you can import specific functions or classes from modules within the package, and make them directly accessible when the package is imported. This can help you present a clean and simplified API to users of your package. Section 8. Structuring your code base. Best practices for real-world projects. Organizing your code effectively is crucial for building maintainable and scalable Python projects. A well-structured code base not only makes it easier for you to manage your project, but also helps other developers understand and contribute to it more efficiently. Here are some best practices to consider when structuring your code base to ensure it remains clean, organized, and easy to navigate. First, follow PEP 8 Style Guide. Adhering to the PEP 8 Style Guide ensures consistency and readability across your code base. This style guide is widely accepted in the Python community and covers various aspects of writing clean code. It covers naming conventions, indentation, line length, and other stylistic aspects. By following these guidelines, you make your code more predictable and easier to read, which is especially important when working in a team. Second, use meaningful names. Choose descriptive and meaningful names for your modules, packages, functions, classes, and variables. Avoid using vague or generic names that don't convey the purpose of the code. This makes your code easier to understand and navigate. When other developers look at your code, they should be able to grasp its functionality quickly without needing extensive documentation. Third, keep modules small and focused. Aim to keep your modules small and focused on a specific task or functionality. Large, monolithic modules can become difficult to manage and debug. This promotes code reusability and maintainability. Smaller modules are easier to test and can be reused in different parts of your project or even in other projects. Fourth, group related code together. Organize your code into logical groups based on functionality. This helps in keeping your code base organized and makes it easier to locate specific pieces of code. For example, you could have separate modules for data processing, user interface elements, or network operations. This separation of concerns makes your code base more modular and easier to manage. Finally, use virtual environments. Virtual environments isolate your project dependencies, preventing conflicts between different projects. This is particularly useful when working on multiple projects that require different versions of the same library. This ensures that your project uses the correct versions of external libraries. By isolating dependencies, you can avoid the "it works on my machine" problem and ensure that your project runs smoothly in different environments. Section 9. Putting it all together, an example project. Let's illustrate these concepts with a simple example. Imagine you're building a program to analyze text data. You could structure your project like this: text.py file. Inside, you have with its own, and then there's also with an, and finally, there's. In this structure is the main package, and our sub-packages for utility functions and analysis modules respectively. Each Python file, etc., represents a module containing specific functionalities. This organization allows you to easily locate and work on different aspects of your text analysis project. It also promotes code reusability, as you can import and use modules like or in other projects as well. Section 10. Conclusion. Writing better Python code. Mastering modules, imports, and code organization is essential for every Python developer. These concepts empower you to write cleaner, more maintainable, and scalable code. By breaking down your projects into logical units, you enhance code reusability and make collaboration easier. Remember to follow best practices, leverage the power of packages, and always strive for a well-organized code base. By doing so, you'll be well equipped to tackle complex projects and write Python code that is both